Hi, Maria.
Hi, Andres.
I have been thinking about the experiments we completed last week, in which we found that not only the levels of neutrophils in blood change during the day, that is, they follow circadian cycles, it is intriguing that the phenotype also changes, with reductions in size, hypersegmentation of the nucleus, and alterations in the repertoire of receptors when they're about to be cleared from blood. I think we should look into how and for what purpose neutrophils are cleared.
Oh, I think I have a very interesting observation. When I increase the number of these H neutrophils in blood, either by transfer or by connecting the circulation of a normal mouse with one that is neutrophilic, I see an increase in the number of hematopoietic progenitors in blood. However, when I deplete neutrophils from blood, the number of progenitors drops by half.
That is interesting. Since hematopoietic progenitors are stored mostly in the bone marrow, I think we should look into what happens in this organ.
Funny you should mention that. Using the CXCL12 GFP mice, where we can follow the CXCL12 producing cells that form the niches that retain blood stem cells, I find that neutrophil transfer reduces both the number of niche cells and the levels of CXCL12. In contrast, when I deplete endogenous neutrophils, the number of niche cells and the levels of CXCL12 go up.
Good. So what do you think is going on in the bone marrow?
Hi guys, I heard you talking. And if we use multiphoton intravital microscopy, it turns out that H neutrophils enter the bone marrow and associate with macrophages, but not with CXCL12 producing niche cells. And also, we can show by flow cytometry that H neutrophils are preferentially engulfed by bone marrow macrophages.
Exciting! Can we demonstrate that these macrophages are required for the niche modulating functions of neutrophils?
Yes, we can. I have depleted bone marrow macrophages with clodronate liposomes, and the effect on neutrophils on blood progenitors and CXCL12 in the bone marrow is gone.
Nice. So macrophages are essential for mediating these effects on the hematopoietic niche. But how do they do that?
Can I suggest something? There is a group of nuclear receptors, the LXR, that are activated in macrophages when they inject apoptotic cells. So that might be a possibility.
Let's look into this. Chris, can you run this experiment?
Well, actually, I have done some things already. I have followed the levels of two LXR target genes in the bone marrow over a full day. They follow very nice circadian changes, and their levels go up just when neutrophils are being cleared.
Also, we've analyzed mice that lack both isoforms of LXR, and they fail to respond with changes in hematopoietic progenitors and CXCL12 when we inject H neutrophils.
Okay guys, now that we know what is going on in the bone marrow, I think we should run a circadian experiment to test whether neutrophils are mediating the circadian fluctuations of progenitors in the periphery, as demonstrated by our collaborators in the Rhythmic lab. What do you think?
It's perfect.
It's okay.
Okay.
Awesome.
So let's do it. Was I dreaming? Yes?
May I come in?
Yes, come in, Maria.
Andres, we have done the circadian experiment we discussed. It turns out that if we deplete endogenous neutrophils or macrophages, the circadian fluctuations of hematopoietic progenitors in blood disappear. Interestingly, the fluctuations in LXR target genes are also gone in these mice.
Exciting, Maria. So let me recapitulate. We find that neutrophils age in blood and are clear at specific times. They infiltrate the bone marrow and are taken up by resident macrophages, and LSR receptors are activated. These events lead to reductions in the number of niche cells and the chemokine CXCL12, leading to the release of hematopoietic progenitors into the circulation. And all this is choreographed during the course of 24 hours.
So then, does this mean that neutrophil clearance dictates homeostatic changes in the hematopoietic niche? And that immune cells and hematopoietic niches are coordinated?
That's right. It will also be interesting to search for additional roles for these H neutrophils.
Andres, I think we should try to publish this in Cell.